This is the week 16 review, which is a review for the quadratics test. So I'm going to kind of go through some of the answers, give you some explanations. So first thing here, directions are solve, and it says use the square root property. So that means we want to get the squared term by itself and then take the square root. So here I don't have a squared term by itself. I can divide both sides by 2. Now the squared term is by itself, so I can take the square root of both sides to solve. Remember, there's always 2 roots, and 125 can be broken down into 2 squares. So I know that 25 goes in there because there's 5 quarters in $1.25. Anytime you have things that look like money, you can divide it by 25. So your final answer is plus or minus 5 radical 5. So it was not a perfect square. If you want to check to see if this is right, you can take the square root of each of those and see if they're the same thing. Okay, the second one is if there's a variable and a constant involved inside the parentheses, but still you make sure the squared is by itself. So it is. So I take the square root. The square root gets rid of the squared, but it leaves x minus 2, and I have plus or minus 4. So to finish this, I still need to add 2 to both sides. So x equals 2 plus or minus 4. And I always go ahead and find out what those 2 values are. 2 plus 4 is 6. 2 minus 4 is negative 2. And if you look back at your original problem, you say 6 minus 2 squared or negative 2 minus 2 squared, they're both 16. Solve using the zero product property. So we're solving, zero product means I'm going to try to factor it first. So we have a few of these show up. A lot of times when we're factoring, you're thinking guess and check. But if you remember your factoring review, if there was 2 terms, you could do difference of 2 squares or GCF. You can't do guess and check with 2 terms. So I can't do difference of squares, but I can take out the GCF, which is 5x. Leaves me with x minus 3 equals 0. And then you set both of these equal to 0 to solve. So one of the solutions is 0, and one of the solutions would be 3. Now this one usually you can do in your head. People forget, and they often call that negative 5. 5 times 0 is 0. Okay, so this next one, I cannot factor it until I get everything equal to 0. The zero product property only works when there is everything equal to 0. That's why it's called the zero product property. Now I can do guess and check. I know I have x and x. 2 numbers that multiply to give me 6 are 3 and 2, or 6 and 1. 3 and 2. 3x plus 2x is 5x, so I can put those in. So that's factored. It's not solved yet. Solve it. I see what makes that 0. So negative 3 makes this 0. Negative 2 makes that 0. Okay, we'll go to the next slide. Solve using the quadratic formula. So again, if you have a choice, this one I would try to factor first, but we'll use the quadratic formula. Number A is the first term, B is the second term, and C is the third term. Signs are important. So opposite of B, plus or minus square root b squared, put in parentheses, minus 4 times a times c, all over 2 times a. This is the most important step, as we're double checking. Do that inside of the square root, inside of the radicand. Do that on your calculator. You end up getting 16. Square root of 16 is 4. So I have 2 plus 4 over 6 and 2 minus 4 over 6. That equals 1. That equals negative 2 over 6, which is negative 1/3. Again, quadratic formula, like the zero product property, only works when you set it equal to 0. So I'm going to subtract 3 from both sides and do the quadratic formula. There's a 1 there. So opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. This step's the most important. Negative 1 plus or minus square root, that's 61. And then you can see if something goes into 61, but 9 would be the first odd one, and then 25, none of those go in there, so you can just leave it like this. If you want, you can write it out as negative 1 plus radical 61 over 10 and minus. Sketch a graph whose zeros are 4, negative 2, and has a maximum. So it's going to be kind of hard to make a point there, but 4 and negative 2. If it has a maximum, it's upside down parabola. So something like that. You could have it higher than that, but everything's going to go through those 2 points. Sketch a graph that has no real solutions. That means it does not cross the x-axis. Axis of symmetry is at negative 2. So I put my axis of symmetry on there. It has a minimum, so that means it's opening up. That's a minimum. So it has to be up here somewhere. It could be anything up here. Can't touch the x-axis. Cannot be down below because it's eventually going to cross the x-axis. So those cannot be answers. Calculate the vertex. Whoops. So x equals negative b over 2a. That gives me negative 1. That's my x coordinate. And I plug in negative 1 to find the y coordinate. So 2 minus 11, negative 9. That would be a minimum, because I know if the 2 is positive, it's a parabola opening up. Didn't ask that. It says calculate the x-intercept, zeros, roots. So it's already factored for us. So the zeros are the solutions to this, each of these equations. So we have 2/3 and negative 7, 2 solutions. Mr. Du Bois takes his bow and arrow out to see how far he can shoot it. The flight of the arrow can be modeled by the following equation. Okay, so I'm going to make a picture. And I'm looking for a couple of things. First of all, I'm looking for if there's a starting height. Are we starting, if there's no C value, we're starting on the ground. But he's starting at 5.75. It's going up, and it's hitting the ground somehow. Okay, so I know this is 5.75. So that's the answer to how far off the ground is the arrow when it's fired. How long does it take to reach the maximum? So this is time and this is height. So how long does it take? I need to find the vertex, and I'm talking about the x-coordinate of the vertex. So negative b over 2a and negative 32 over, or negative 80 over 32. You can use your calculator to reduce it and get 5 halves, 2.5. And that is this in seconds. So I know that the x-coordinate of my vertex is 2.5. What is the maximum height? So if I know when the maximum occurs, I can plug in that time to find the height. So the Vertex always is going to tell you two different answers. You have to read the problem to make sure. I'm going to go ahead and plug that in my calculator. You do the same. Plus 80 times 2.5. And you get 105.75. If you do as a fraction, that's fine. And it's worth checking the value feet. So that is the maximum height of the arrow. How long does it take for the arrow to hit the ground? Okay, so that means I'm trying to find this value over here, which is the 0, which means I have to solve. And the only way, I'm not going to factor this. You could factor it if you're a glutton for punishment. The only way to solve it that makes sense is to do the quadratic formula. So opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. So I did it on my calculator. So I have negative 80 plus or minus the square root of 6,768 over negative 32. The square root of 6,768, 82.3. So I have negative 80 plus or minus 82.3 over negative 32. Now there's only one answer there that's going to work, and that's the negative 80 minus 82.3. Because if you do plus, you're going to get a negative time, which unless you're Michael J. Fox, you can go back in time. It won't work. So 5.07, that's your decimal estimate. Okay, so anytime we're talking about word problems, right here is when it hits the ground. Right here is the maximum height. Dang it. Sorry. Maximum height is there. Time to hit the ground is here. Starting height is here. So make sure that you remember that that's the only thing they can ask you. So you're looking for the keyword maximum. But notice maximum could be height. It could be time. So make sure you just read the question. Other things to be concerned about for this test. I would make sure that I know how to factor. And remember our review of factoring. If there's two terms, you can do difference of two squares, or you can do GCF. Probably it's going to be something like this. You're probably not going to have to do difference of two squares, but if there's two terms, if there's three terms, that's when we do our guess and check. Make sure that you always check your outside and inside terms. So the middle term of my polynomial for this one would have been negative 23. You always want to check, especially if these signs are opposite. If there's four terms, you factor by, the only way we factor is by grouping. So you pair up the first two and the last two. The other thing that didn't come up in this review that could is if you're doing a quadratic formula and you get a negative, when you go to simplify, if there's a negative here, first of all, double check the strokes in your calculator, make sure you didn't forget a negative, but that means that there are imaginary solutions. That means it doesn't ever cross. So you have something like this. It doesn't ever cross the x-axis. So you just write imaginary solutions, or no real solutions. We didn't talk about how to find the imaginary ones. That'll be an Algebra 2 topic. It's always worth making sure you're really careful if you're using your calculator. Double check your entries. You can do really well.